welcome to week 7 of Web Design Decal. This week for the design portion, we'll be talking about responsive design, and this goes hand in hand with the programming lecture for this week, which is also about responsive programming. So this is Diana. Sorry for the delay, but also we're running into a lot of technological issues, and this is also my first time recording lecture remotely on my laptop, so hopefully nothing goes wrong. And sorry if it's a little stiff or awkward. I'm just gonna try my best. And also sorry if there's a little noise in the background because I have a dog in my house. So yeah, okay. Sorry. Moving forward, we're gonna talk about responsive design this week. And cool. So the state of the internet right now is pretty broad. It's the capabilities of the internet. Oh man, don't even get me started. But yeah, as you can see, nearly 4.4 billion people on this earth have access to the internet today, and it's all accessible from all kind of devices, including your very own laptops and desktops, tablets, smartphones, game consoles, smartwatches. I've never heard of a microwave, but there's definitely fridges, because I don't know about you, but I've seen those tweets before that say tweeted from LG smart fridge. But yeah, the internet can be accessed from many different devices nowadays, and we're pretty much practically in the post PC era, meaning that our computers are actually not our primary devices used to access the internet anymore. In fact, more people on the internet access it through a mobile device instead of their desktop computer. In fact, I think back in 2018, the mobile internet usage was around 48.2%. So if that was 2 years ago, you can probably imagine what it's like now, given with the fact that having a phone pretty much puts the internet in your pocket wherever you go. So that's really convenient, really. So yeah, this is just a really quick graph of how from Vox, and it was just an article about how Apple's iPhone really changed the world within the past 10 years. You can see now in bright red that mobile internet actually exceeds the amount of time spent than desktop internet. And if you're one of those people who get in the trap of scrolling across Instagram endlessly or Twitter, I completely understand. But yeah, this is what people are used to nowadays. And in fact, mobile ad spending is expected to surpass desktop ad spending as well nowadays too. So yeah, designing for mobile interface, incredibly important, because we as people have proven that we're continuing to spend more and more time on it. So you might be wondering sometimes, you've probably run into this issue while working on your group project for Kingpin Donuts, that if you have a different screen size than your partner, you might notice that some positioning of some things might be off, or it's just not exactly what it looks like on your partner's screen. So yeah, why won't my site work on all devices? Well, again, everyone has a different screen resolution, so this is we'll get into this later, but as you can see here, this is just an example of a 1280 pixel screen and on top overlaid is a 300 pixel box. However, your phone only has so much space. So if you were to load the same website that you made from scratch onto your phone, it'd probably only showcase as much as it could, because it's constricted to the width, physically on the phone screen, constricted to that width. So yeah. And just to give a quick inspector demo, what do you mean by not a non-responsive website, right? So I'm actually going to show you guys with Kingpin Donuts. This is homepage. This is actually a little different from when we last saw it. They actually have a playlist now, or a song in the corner here. Background's a solid pink. They have a link to their Facebook page. But nevertheless, we want to see if it's responsive, right? So I'm gonna click out of the full screen view right now, and let's take a look at what happens if I resize my window. So I'm just gonna make it smaller, see what happens. And oh, that's probably not ideal, right? If you say you want to resize your screen, but you still want to access every single element, you don't want to be scrolling back and forth just to be able to access those elements. So this is what we mean by responsive. It's only responsive to a certain extent, and when it starts getting too crowded, it won't be able to fit all those UI elements anymore. So that's what we mean by non-responsive. So yeah. On the other hand, if we were to look at a better example, I've pulled up Stripe's landing page again right here. And you can see that right now it takes up this entire space. But if I were to resize it, you might be wondering, oh, what's going to happen to the graphics or maybe the text? And you can see right now already the nav bar at the top here, all this information right here is already moving to be proportionally like the same. Like, how do I explain this? Well, it's not being cut off for one, and even as I move in, you can see this drastic distance right here actually, or difference, I mean, that it actually, the font size, once it registers that the window is less than a certain width, the font size has actually responded to be smaller, and this graphic down here has changed to be different, to be narrower, if that makes sense. In fact, it changed to be a mobile interface example. I don't know if that was totally intentional if you were to view this on mobile, but yeah. You can see how each UI element is responding to the like shrinking size of the web page to the point where when I make it really small, it actually gets rid of the graphic completely. Whereas if we go back to Kingpin Donuts, everything is, being squished in right here. So that's obviously not ideal, but this is like really cool, where everything here is still readable. It's a little condensed, but it's not like, it still works as a website. All right, everything still works and is completely readable. Yeah. So that's what we essentially mean by responsive design. Cool. Moving forward. Yeah, and Google actually has this really cool feature where if you just type in like Google mobile friendly test and you enter in your like, I guess, website of interest, it'll tell you whether your page is mobile friendly or not. So yeah. Again, so to reiterate, different devices come with different screen sizes and rendering engines. And so by rendering engine, we mean it's also known as a browser engine. And that's basically a core software component of every major web browser, like Google Chrome or Safari or Firefox. And the primary job of this rendering engine is to transform your HTML documents, your HTML code, and your like CSS, your cascading style sheets, and any other resources of a web page into an interactive visual representation on a user's device. And I guess like TLDR, the rendering engine is responsible for transforming your code into what it actually looks like. And different browsers actually have different rendering engines, but we'll get into that later. So content designed for a laptop with a much bigger screen won't look exactly the same on a tablet or mobile device with a much smaller screen, right? So what does this mean for designers? Well, we need to make sure our websites work on all devices and all different kinds of browsers, right? And that's what being responsive means. Yeah, so designing websites for multiple screen sizes and devices so that there is an optimal experience for every user at every possible size. You don't want to take a survey and say, oh, we'll only design for the browser that is most commonly used and the device that is most commonly used, right? Because not everyone has the same device or the same screen size. So you want to make sure your design works for everyone. And so, again, we've been talking about these terms now, but responsive design essentially deals with three major components. 1, browser compatibility. 2, screen resolutions. And 3, mobile compatibility. And so we'll be exploring each of these aspects today. So issue 1, browser compatibility. I've already touched upon a little bit of rendering engines and different kind of browsers, but basically browser compatibility is the ability of a website to function as expected on any web browser. Like I said before, browsers have different rendering engines, and this is just a reiteration, but basically each browser sometimes can interpret your code differently. So, for example, Chrome and Safari both use a rendering engine called WebKit. I think Mozilla uses Gecko. Microsoft, if you use Internet Explorer, still uses a browser engine called Trident, and then Opera uses something called Presto. But these are just like names I'm throwing around as examples of different kind of browser engines. But the point is that some of these interpret your CSS differently, and that's actually why they might look a little different. So I think most of us have Macs and use Google Chrome. We did ask everyone to install Google Chrome, I think on the first day of class, or like people were using Safari. So you may not have noticed this, but I think some people with different browser engines have, for their homework too, actually, when we asked you guys to add a dotted border for some of the fancy circles or the fancy squares, some of the dotted borders actually looked different because different rendering engines interpret this CSS styling differently. So you can see for Internet Explorer 7, it'll be this. 8 is a little similar, but when we look at Firefox and Safari, they look very different, right? These tend to look more like little diamonds, whereas this is a dot, and these are like dashed rectangles, yada, yada, yada. So you get the point. Different browser engines render things differently. So what can we do to solve this? Like, how do we keep consistency across different browser engines? And, well, we use something called vendor prefixes. What a vendor prefix essentially is like this line right here, this property. We have this WebKit transition. These are just the names. So WebKit, like I mentioned before, is the browser engine for Chrome and Safari, and what this line essentially means that it's specifying that the opacity for this rendering engine should be at like 0.3, something like that. And Moz, I believe, is for Firefox. O might be for Opera. I'm not sure, but you guys can look into it. But the point is that if you want your CSS to look consistent across different browsers, you might want to look into these vendor prefixes and play around with some of these values so that they look the same across all of them. So yeah. Another cool thing to look at actually is this website called caniuse.com, which I'll actually take you guys to right now. So caniuse.com actually lets you know what features are supported across different browser engines. And so, for example, I think the most recent thing we learned in programming was Flexbox, right? So let's take a look. Can we use Flexbox across different browser engines? If we take a look at this graph, I think you can see that here across Chrome and Safari, it's pretty good for these versions. But however, if you were to try and use, I think, Flexbox for Opera at this specific browser version, it would not work at all. So yeah, it's just cool. These are really nitpicky things, but I guess very important if you want to get into front end and make sure your website works across all different kinds of browsers. Moving forward. So yeah, there's some limitations when it comes to vendor prefixes. Usually these are for like simple things, so like linear gradients, transitions, we mentioned before, like opacity, but there might be some more complicated things that you might not be able to standardize across different browser engines. Instead of vendor prefixes, a lot of major browsers are moving away from these things and actually towards at supports or feature queries. Don't get too worried if you don't understand what that means. This is just like another feature of CSS. It's like another rule that lets you specify declarations that depend on a browser's support for one or more specific CSS features. It's not in the scope of this class, but you're totally free to research this on your own. Cool. So now that we've dealt with browser compatibility, we have a second issue, which I think was the most noticeable when you guys were working on your project, different screen resolutions. So what resolution essentially is how many pixels your screen can display horizontally and vertically. You might have heard, I think the most common screens, actually, well, the one I'm working on right now, this is a MacBook Pro 2018 version. I think this is a 13-inch, so my screen resolution, I think is, well, that's what this link is for. You can actually go to this. My screen resolution apparently is 1440 by 900. And yes, this number represents your screen monitor resolution in width and height and lets you know how many pixels can fit. So this essentially means like I can fit 1440 pixels vertically or horizontally and 900 pixels vertically on the screen. Yeah, so not all users will view your website on devices with the same screen size resolution. So the 13-inch MacBook Pro does not have the same screen resolution as the 15 MacBook Pro. And changing the size of your browser window also affects how your website looks, as I showed earlier with Kingpin Donuts and Stripe, right? So this is actually a survey done in 2018. I actually checked up recently, as of 2020. The stats are pretty much about the same, but the most common browser viewing sizes are around here. The chart pretty much speaks for its own. So what does that mean? Should we only design for one type of screen size? Actually, no. What actually helps is to use containers to make your content fit a certain size. So using a container size of 1024 by 768 is ideal because all screen resolutions greater than or equal to the size of the container will have a good viewing experience. If we look back here, we can see that 1024 by 768 is actually like one of the smallest. There's some smaller, but I'm going to assume that this is in reference to mobile screen resolutions. But if we look at this essentially means that if we start small, if we make all of our container or our major containers this compatible for this viewing size, this just means that it will be visible for any screen size larger than that, right? So if we resize, it won't be cramped. So this is what I mean here. To the right would be example of perhaps like a smaller screen resolution size. So we want to design our container size to be to fit the smallest one, like to take up the most room on the smallest screen resolution size, so that when it is viewed in a device with a larger screen resolution, it's not like disgustingly stretched out, or it's like there's enough space and it's still visible. Yeah. As for lower screen resolutions, like things that have very specific values, this is actually addressed in our programming lecture this week by Heidi, CSS media queries. So if you want to learn about that, please go watch the programming lecture for this week. Yeah, so moving on to issue 3, we have the problem of mobile compatibility, right? Everything on your desktop is not necessarily going to look the same as it does on your phone. So User interfaces for mobile websites are quite different than those for desktop. Well, and they differ in three main ways. One, obviously, the screen size. I'd say like your typical iPhone or handheld device is probably like anywhere from a sixth to like takes up only a sixth or like a seventh of your actual like laptop or computer screen size, right? So it's much smaller. Two, they have touchscreen capabilities, right? Instead of using like a trackpad or a mouse to navigate this big space on your screen, you're using your hand, your thumbs mainly. And three, performance, which I'll get into on the next slide. So, mobile versus desktop. Again, screen size, much smaller. Your input method is your thumb using the touchscreen, and the performance, you see, the rendering engines for phones is actually much slower than it is for desktop. So, you probably have to keep this in mind when it comes to embedding certain types of media for the phone, and you want to make sure it's like the file type is compatible with all kind of devices. Yeah. So again, screen size, much smaller. So what does that mean as a designer? It probably means that you want to focus on the most important content and tuck everything else away into either something that can be easily accessed, but it shouldn't take up like extra space on the page. And due to the restricted space, most UIs should stack elements vertically, so this helps maximize the width and emphasis on each element. For example, if we look at this, the dailycal.org, the mobile website, this image right here takes up the entire width of the screen. You don't want to see multiple different news, like, news images, because you want to focus on one thing at a time to be able to actually even like distinguish what the image is showing. Also, you want to restrict your use of position fixed elements. Usually that means our nav bars or anything at the bottom, like as well, because they reduce space for content. Remember, you're only given like, I don't know, at most like 5 inches of vertical space to display information, and that's like much more precious than your big wide screen of a laptop, right? So anything that's fixed on this little mobile screen is already taking up a lot of space. So generally that's why they're tucked away in these little menus like this, or like the search bar here. But you probably only want to like keep, I don't know, like a top nav bar, but you don't want to have too many fixed elements because you've only got this much space to work with. But yeah. Two, right. So we have this different way of navigating our mobile devices, right? Using our hands. According to this graph, most people tend to use their phone one-handed, including myself, using your thumb really to navigate the most important things on your screen. So we probably want to keep that in mind when it comes to the placement of certain UI elements. So this is just a really cool graph of like the reachability of people's thumbs, which I assume is going to be your primary way of accessing things. I know there are people who probably hold their phone with one hand and possibly use their index finger, but this is, I guess, for the group of people who just use their thumbs. So you can see in the green area, that's like good. Like that's where things can be easily reached with your thumb. And then the yellow area is kind of like, yeah, I guess I can get to it. And then obviously the purple is like very hard to reach unless you like shift your phone in your hand or you readjust and use your index finger instead, using 2 hands. So this graph goes to show that reachability has its physical limits, right? So what does that mean? Well, one, our thumbs are less precise than cursors. So we want to make sure you want to, for anything that's in the easy thumb zone, I suppose what is what we're calling it, has like generous amount of space to accommodate for people's like thumbs, like to be able to hit those UI elements and call to action elements much more easily. Yeah, and these should definitely be placed at the bottom of the screen to improve reachability. I mean, the whole point is shown here. I know since then, obviously, Apple has released phones without the home button, but the home button before existed at the bottom just so you could, because it's the most commonly used item, right? To go back to the home and then access any other apps that you need from there. Well, I mean, even without the home button, we're still swiping at the bottom, right? To get to our home screen, right? It doesn't change the fact that the things that we need most are being put at the bottom. And again, this is just like a general point for mobile accessibility. Mobile UI elements should have accessible dimensions, meaning that if you have this tiny, tiny, tiny button right here, actually two of them that are right next to each other, how are you going to distinguish pressing, cancel and save, right? If they're so small. So you want to make sure there's ample space to be able to distinguish, or for the screen to distinguish where the finger should be hitting to, choose that certain action. Or in case that, I guess, if you have something that is a critical action, maybe like canceling payment or paying for something that's like very important, or something, that needs a little more thought behind it, you might want to place them where they can't accidentally be hit, right? So if we take a look at Lyft's mobile user interface here, you can notice that between the three screens, starting just from where you're entering your destination, where your Lyft is, and just more driver information, everything, all this important information is at the bottom, right? Where the user can access these things much more easily than if they were at the top. And this is just a quick guide from a while ago, from 2014, but I don't know if you guys ever still remember this, but the whole reachability solution for people who possibly quite can't access all the space is that they would double tap the home button, right? And the entire top half of the screen would shift down. And in fact, even when Apple or iOS, with the update, they removed the home button. I think I actually don't own an iPhone 10 or X, but I know that when you swipe down at the bottom here, that triggers the reachability solution. So that just goes to show that you should constantly be thinking of innovative ways to solve these reachability issues or things like that, taking accessibility to the next level, right? So cool. Moving on to the third portion, performance. Rendering performance on mobile is roughly half that of desktop browser engines. So sometimes this causes mobile websites to be slow, especially those with really heavy graphics, like moving images or videos, things like that. So what does that mean? Well, if you want your website to be mobile friendly, possibly consider having the mobile version minimize JavaScript front end manipulation. So maybe minimize your transitions, animations, hover effects, because we are this is, it's a slower engine, obviously. Most mobile UIs are simply just clicking and scrolling, and pretty static, actually. And so we've presented a lot of problems, right, when it comes to differences in browser compatibility, screen resolution, and performance, right? So I think our solution, or what most people think should be a solution to these problems, is mobile first design. So what does that mean? Mobile first design is actually a design strategy that says whenever you want to start to create a website or an app, you should actually start sketching and prototyping the smallest screen first. and work your way up to larger screens. Because essentially, it's about delivering the right user experience to the right device, right? It's harder to squash things down from like a big screen, right, that has a lot of UI elements into to fit in more things into a smaller space than opening things up and adding more things to fill a larger space. So design for mobile first and then design for larger screens. We're not necessarily saying that this has to be the like this has to be the way you do things from now on or with regards to your final project, but I think it's just like something you might want to consider. Because designing for mobile essentially really asks you to consider what are the bare bones of your website. What is the most important things, right? The things that you want to click and scroll on, right? What's like visual hierarchy on a mobile device is even more pressing than it is on a larger screen because it really narrows what you think is important. And also, again, like I said before, it takes accessibility to the next level. Um, this is a little off tangent, but like sometimes you might even want to consider providing a voiceover or a talkback solution for users to enhance accessibility to the use of appropriate tags for like tables and forms and contents when someone's browsing your phone, right? So yeah, again, review. Well, responsive design. What does that mean? Designing for variation is important. You want to be able to design for all different kinds of browsers, add prefixes if necessary, and you want to make sure it works well on all devices, no matter what the screen size resolution is, or if it's a mobile or a desktop device, right? So yeah, I think that's all we have for this week on responsive design. Make sure to keep, I guess, please keep watching lecture. Please come to us at office hours online if you need help, or email us if you have questions about the project or any homework. But yeah, and again, for attendance, we have these. This week's attendance is actually in the form of a mid-semester feedback form, which is located in the programming lecture, and you can find it online on the portal as well. And with that, thanks everyone for tuning in to this week's lecture. Sorry it was a little late, but we decided to give you guys a break. Your homework is pretty much just the mid-semester feedback form. Make sure you turn in your project, and yeah, stay healthy, stay safe, everyone, and yeah, bye.